questions 11 through 20 on the 2011 grade 11 Fermat math contest. A gumball machine that randomly dispenses one gumball at a time contains 13 red, 5 blue, 1 white, and 9 green gumballs. What is the least number of gumballs that Wally must buy to guarantee that he receives 3 gumballs of the same color? Notice the spelling of color. That indicates for sure that this is a Canadian math contest. Anyhow, so we've got 13 red, 5 blue, 1 white, and 9 green. So let's say in his first round of choosing, he chooses a red, a blue, a white, and a green. We spread it out so that he's not going to select 3 gumballs of the same color. Okay, well, since there's only 1 white, that's gone. We've already chosen the white. Let's go to the second round. And again, I'm going to spread it out so that he doesn't choose 3 of the same color. So I choose red, a blue, and a green. Now, at this point, the very next gumball he chooses guarantees that he will get 3 of the same color. For example, the very next gumball, I can only choose between red, blue, and green, right? Because the white is already done. If I choose a red, there you go. I've got 3 of the same color. Instead of choosing red, let's say I chose a blue. Well, that also guarantees 3 of the same color. Instead of choosing blue, if I chose green, again, it guarantees 3 of the same color. So how many did I choose? 1, 2, 3, 4, 5, 6, 7, 8. 8 is the least number of gumballs that Wally must buy to guarantee that he receives 3 gumballs of the same color. So number 11, the answer is E. In the diagram, the parabola has x-intercepts -1 and 4 and y-intercepts of 8. If the parabola passes through the point 3w, what is w? The equation of this parabola is written as y is equal to some a, and then we know the roots, so x minus 4, x plus 1. It's the quickest way of figuring out the equation with the roots. Well, they gave me a very important and helpful tool, that is this value, which is the y-intercept. And that means that point, which is 0, 8, is on that parabola. So substitute it in, 8 for y, and you get a, 0 minus 4, and 0 plus 1. And that means 8 is equal to a, and that looks like -4 plus 1, -4, and therefore a is -2. So very quickly, we've got our equation. It's -2 times x minus 4 times x plus 1. And now they've given me this point 3w, and they're saying that it's on the parabola. Okay, so substitute it in, 3 and w. So 3 for x and w for y. So we got 3 minus 4 and 3 plus 1. So w is -2, -1, and 4. So that means w is 8. So number 12, the answer is 8, which is choice E. Xavier, Yolanda, and Ji Xuan have a total of $50. The ratio of the amount Xavier has to the total amount Yolanda and Ji Xuan have is 3/2. Yolanda has $4 more than Ji Xuan. How much does Ji Xuan have? All right, so we've got X, Y, and Z. Those are the first letters of the names. And one thing we know for sure is that X plus Y plus Z is 50, because the total is $50. Then they give us a ratio that X over Y plus Z is 3/2. And the final piece of information they give me is that Y is equal to Z plus 4. So these pieces of information are entirely from the question stem, not from me. So we've got 3 equations, 3 variables we have to solve. So any way you wish to solve this is appropriate as long as you get the right answer. I'll call this equation 1. Equation 2 we can get just by cross multiplying. It'll be 2x is equal to 3y plus 3z. And then equation 3 is just right there. So like I said, however you want to do this is fine. I'm going to do equation 2 minus 2 times equation 1. So if I do that, I get the following. I get 2x minus 2y minus 2z is equal to, and on the other side it would be 3y plus 3z minus 100. Simplifying this, we get 100 is equal to 5y plus 5z, and divide through by 5 and you get y plus z is equal to 20. So I guess at this point we can just substitute that into this new equation, and that would mean 20 is equal to z plus 4 plus z. So that means 20 is equal to 2z plus 4. 16 is therefore equal to 2z, and therefore z is equal to 8. And that is what the question is asking for. How much does Z Schwan have? And that's $8, and therefore number 13, the answer is B. Which of the following must be an even integer? So let's just use some numbers. That I always do it that way. It makes it easier. Average of two integers. Well, let's see. That's anything, right? 6 plus 8 divided by 2. 14 divided by 2, and that's 7. Well, that's not even, so A's out. The average of 2 primes. All right, let's try 2 primes, 2 and 3. The average is 5 over 2, and that's 2.5, and that's not even an integer, so it's certainly not even integer. The average of 2 perfect squares. Okay, so I can say 9 plus 16, those are 2 perfect squares, divided by 2 to get the average. 25 over 2, that's 12.5, so that's not even an integer, so C's out. The average of 2 multiples of 4. Okay, how about 4 and 8? Those are multiples of 4. So that's 12 over 2, and that's 6. Okay, that's even. So let's keep that. Let's try E. The average of 3 consecutive integers. 8, 9, and 10 divided by 3. That is 27 over 3, and that is 9, so that's not even. So by process of elimination, the only one that ends up being even is D. So number 14, the answer is D. If m and n are consecutive positive integers and n squared minus m squared is greater than 20, then the minimum possible value of n squared plus m squared is. Well, m and n are consecutive, so if you have m, this must be equal to m plus 1. They're consecutive. So therefore, this n squared minus m squared greater than 20 that they give you in the question, if you substitute n is equal to m plus 1, we get the following. M plus 1 squared minus m squared is greater than 20. So if you expand this out, you get m squared plus 2m plus 1 minus m squared is greater than 20. The m squareds cancel, and you just get left with 2m plus 1 is greater than 20. Put the 1 on the other side, and you get 2m is greater than 19. And therefore, m is greater than 19 over 2. So therefore, m is greater than 9.5. Now, we are talking about finding minimums, right? So the minimum possible integer that you can have if m is greater than 9.5 is m equal 10, right? And therefore, n is m plus 1. So n will be 10 plus 1, which is 11. And now we have to find the value of that, n squared plus m squared. So n is 11, m is 10, so that's 121 plus 100, and that is 221. So number 15, the answer is E. Six identical rectangles with height h and width w are arranged as shown. Line segment PQ intersects the vertical side of one rectangle at x and the horizontal side of another rectangle at z. If right-angled triangle XYZ has YZ equal to 2XY, then H over W equals. This triangle is very similar to that triangle. So we are going to use similar triangles. Triangle XYZ is similar to triangle I'll just call this O, POQ. So that means that PO over OQ is equal to XY over YZ. Now, this piece of information we will use YZ is equal to 2XY. So if I put the YZ on this side, it becomes 1 over 2 like that. So this part essentially becomes a half. So we substitute that in and just put a half right there. Now PO is what? From here to here, each of these is H, right? So this is H, this is H, and this is H. So PO is 4H. And then OQ, that part, each of these is W. That's W, that's W. So OQ is 3W. So they want us to figure out H over W. So just isolate for H over W. Cross multiply 3 over 4 times 1 over 2. And that is 3 over 8 is H over W. So 16, the answer is 3 over 8, which is C. If 3 to the 2x is equal to 64, then what is the value of 3 to the negative x? I use logs, just makes it easier. And here, if you're in grade 11, I'm certain you know logs by grade 11. Log of 3 to the 2x is the log of 64. And then, of course, by log rules, the 2x comes out front. You have log of 3. And these are all to the base 10, right? If you don't write in a base, it's assumed that it's base 10. So this just becomes 2x is log of 64 over the log of 3. And then you just get out a calculator, type in 64 log, and then divide it by 3 log. And you'll get a number about 3.78 for 2x. And then x, of course, you just divide by 2 and you get approximately 1.89, I think. And then all you have to do now to figure out 3 to the power of negative x, 3 to the power of negative x. And x was 1.8927 to 4 decimal places. And when you do that in your calculator, it will be approximately 0.125. And in fractional form, that's 1 over 8. And that's it. It's very simple with logs. You don't have to use logs, but I used it. It's just easier for me. And the other system, of course, is just to work with decimals. Sorry, not decimals, exponents. So number 17, the answer is 1 over 8, which is E. A 4x4 square piece of paper is cut into 2 identical pieces along its diagonal. The resulting triangular pieces of paper are each cut into 2 identical pieces. Each of the 4 resulting pieces is cut into 2 identical pieces. Each of the 8 new resulting pieces is finally cut into 2 identical pieces. The length of the longest edge of one of these final 16 pieces of paper is... Well, the first 3 they've already given you, right? So I don't need to draw them out. Let's just talk about them. The first one is just a 4x4x4 square, so those sides are all labeled. This one, to figure out all sides, we just use simple Pythagoras. These two are obviously labeled, so the diagonal, we use simple Pythagoras, and that's 4 squared plus 4 squared is equal to, say, call it d squared. And if you do that, we'll just do it here on the side. 4 squared plus 4 squared is d squared. And therefore, that's 2 times 4 squared is d squared. And therefore, d will be 4 root 2. Which is going to be this diagonal, 4 root 2. That length right there. And then what happens is, then you cut it into shape like that. But what's interesting is that that 4 still remains. I'll draw it a little bit bigger here. It becomes something like this. Now, this is 4. And I just took this triangle and just made it a little bit bigger. This is a right angle because when you cut it like that, those diagonals meet at right angles because it's a square. So that means that this and this are the same. How do you know that? Because if that's 90, this is 45 and this is 45, right? And this is going to be the same as that. You basically have chopped the square into 4, and then each of those diagonals is chopped in half. So that means we can easily call this and this x, and we can use Pythagoras once again to figure out the value of x. X squared plus x squared is 4 squared, 2x squared is 16, and therefore x squared is 8, so therefore x is 2 root 2. Okay, so far so good. So it's this side right there that's 2 root 2. So that side right there, 2 root 2. Okay, that's x. Now we've got 2 more scenarios. That is, we got to take one of these guys and chop it in half. Okay, we can do that. It's actually this one right here that we're chopping in half. So we're going to chop it in half, so it's going to look something like this. Right? I just basically cut it down the middle. Now let's talk about the dimensions there. Well, this whole thing was 4, so that means this has got to be 2. This part is x, and that doesn't change, interestingly, so that's 2 root 2. Right? And then this is 90, and this side, even if I don't know what it is, I can easily figure it out using Pythagoras. 2 squared plus y squared is 2 root 2 squared. So that's 4 plus y squared is 4 times 2, which is 8. Therefore, y squared is equal to 4, and y is equal to 2. Okay, y is 2. And now we have one final cut to make, which is cut this in half. So I'll draw that again. Over here, we got to take that and cut it in half like this. And that's the last one. Well, this side doesn't change. That's just 2. This side is going to be this side divided by 2. So that was 2 root 2, so that means this is just going to be root 2. And then again, this is a right angle. So that means I can use Pythagoras once again to figure that out. Well, z squared plus root 2 squared is going to be 2 squared. So that means z squared plus 2 is equal to 4, and therefore z squared is equal to 2. That means z is root 2. And what they're asking for is the longest edge of one of the final 16 pieces. And this is one of the final 16 pieces. The longest edge, obviously, is just 2. Because the other sides are root 2, and root 2 is approximately 1.4. So 2 is the answer. So number 18, that would be choice B. In the diagram, 2 circles are centered at O. Point S is on the larger circle. Point Q is on the point of intersection of OS and the smaller circle. Line segment PR is a chord of the larger circle and touches, that is tangent to, the smaller circle at Q. Note that OS is the perpendicular bisector of PR. If PR is 12 and QS is 4, then the radius of the larger circle is. Let's draw a line from O to P like that. And let's label this now. From P to Q, well, we know that PR is 12 and PQ is half of that, so PQ is 6. O to Q, we don't know, so I'll just call it small r for radius. And then Q to S, they have told me is 4, so that basically means that the distance from the edge of the small circle to the big circle is 4, no matter where that is. So that means this distance is also 4, right there. And then, of course, from here to here is just the small radius r. So this gives us a Pythagorean relationship, and that is that 6 squared plus r squared is equal to 4 plus r squared, like that. And that's pretty much it. So expanding, you get 36 plus r squared is 16 plus 8r plus r squared. And the r squares disappear, so this becomes 20 is equal to 8r. And therefore r looks like 20 over 8, which is 10 over 4, which is 5 over 2. And in fractions, that's 2.5, right? But we are asked to find the radius of the larger circle. Okay, that's not a problem. The large area, or sorry, the large radius is this red line that I drew. And that red line, if I call it big R, is 4 plus small r. Well, small r I just figured out was 2.5, so it's 4 plus 2.5, which is 6.5. And therefore, number 19, 6.5, would give you choice C. 3 real numbers A, B, C have a sum of 114 and a product of 46, 6, 5, 6. If B equals AR and C equals AR squared for some real number R, then the value of A plus C is. Well, we have A plus B plus C is 114, according to the question. And A times B times C is this big long number 46656. But they give us a couple of clues here that's very helpful, that B is equal to AR and C equals AR. So substitute those into here. And if I do, I get A plus AR plus AR squared is equal to 114. And then if I substitute those same values into that one, I get A times AR times AR squared is equal to 46656. All right, now this one becomes A to the power of 3, R to the power of 3. And then now, as I'm sure you can figure out, you take the cube root of both sides. And that allows you to get rid of the cubes, I guess. So this just becomes AR. And then the cube root of 46656, and you're allowed to use a calculator on the Canadian math contests, and that is 36. So there we go. We got a very nice result. Isolate for one of these. Either one, it doesn't really matter. I'll just do R, 36 over A. And then now we use this, substitute it into this, and that will help us solve for A. So I've got A plus A times R, but R is 36 over A, plus A times R squared, so I got 36 squared over A squared. And that is equal to 114. Okay, multiply through by, let's see here. Well, let me just simplify this first. This is going to be A 36 plus 36 squared over A is 114. Multiply through by A. So I have A squared plus 36A plus 36 squared is equal to 114. And 114A, don't forget to multiply that one. That would be very important. So I guess put everything on one side at this point, minus 78A, and then 36 squared is 1296. And at this point, it's up to you if you can factor it or if you want to use a quadratic. It's really your choice. This actually does factor with integers, so I'll just do it that way. It's 54 and 24 minus minus, so that basically gives you roots of 54 and 24. Give me two values. All right, well, interesting. I didn't expect two values, but it doesn't really matter. Let's just use one of them. I'm going to use the 24. If A is 24, then that means R, using this formula, will be 36 over 24, and that is 1.5. So that means B, which is AR, is going to be 24 times 1.5, and that is 36. And C is AR squared, so that's 24 times 1.5 squared, and that is going to be 54. So what are they asking for? A plus C. Well, that's A and that's C. So A plus C is 24 plus 54, and that is 78. Yeah, that's one of the answers, so might as well choose it. Number 20, the answer is A.